So way back at the start of the course, we talked about gravity. Equation for gravity, force of gravity, is going to be G mass 1 times mass 2 divided by the distance between the two masses squared. Of course, what we realize is that if on Earth we could figure out that this is just G by using the mass of the Earth and the radius of the Earth, and we could figure out, we use those constants, it actually comes out to be G, and that's how the force of gravity, which we also call weight, is mg, where this is your m2, your weight, or your mass, or the mass of your dog, or whatever, and this is just the boiled down form of G mass Earth radius of Earth squared. But for these, we're going to talk about situations mostly where you're not right on the surface of the Earth, where your distance from the Earth can't be considered just the radius of the Earth. Remember, when this formula uses r, it is talking about the distance between the centers of mass of the object. So if this is a satellite, the r in this equation is the distance from the center of the Earth to the satellite, not from the surface. I know for a fact there's at least one problem I give you where they give you this, not this. So it would be helpful to look up and find the radius of the Earth somewhere and add that to the value that they give you. Be careful of that. Because really, when it comes right down to it, if something's moving in a circular orbit around the Earth blue, so if this is an object moving in a circular orbit, the centripetal force is, the net force is the centripetal force, of course, which in this case, the only game in town, is gravity. So that means the centripetal force is equal to the gravitational force, which gives me mv squared over r. Now this m is the thing that is orbiting. It is the satellite. Equals capital G m1 times m2 over a distance between them squared. I guess we would equate that to, call it m2. This and this are the same, we'll say. It really doesn't matter here, they're interchangeable, but so this is the m1, we'll say, is the mass of the planet or whatever, the asteroid, whatever you're orbiting. This is the thing doing the orbiting. Notice that will cancel. And that we end up with the centripetal acceleration, v squared divided by r, equals capital G, mass of the object that's being orbited, the big object, divided by the distance between them squared. Once again, it's not necessarily the radius, and it's not just the distance from the surface to the object. It is the combination of the two, so be aware of that. And that would be your centripetal acceleration. You should be able to solve many, many problems that way. Or at least two, because I think that's what I assigned.